In this video, we are going to study homogeneity of regression slopes with dummy variables in Python using Spyder IDE. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into Spyder IDE. So the first step within the video is we need to import the corresponding packages. Therefore, we have step 1, which is packages. And we're going to import statsModels.api as SM. We're importing that feature from statsModels for data downloading. Then we're going to import statsModels.formula.api as SMF. We're importing that feature from statsModels for multiple linear regression calculation and homogeneity wall test. To run these two code lines, we go ahead, select them, and then we can either click in Run Selection or press F9 on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named housePrices_object, which is equal to, and we are be using SM feature from statsModels.datasets.get_our dataset, and we open parentheses and the following parameters. Data name equals to, and within quotations we have house prices, comma, and we continue at the following row, package equals to, and within quotations AER, comma, cache equals to true. So what we're doing here is the following. We're downloading house prices object from our package AER, and with cache equals to true means that once we download the data, we save it locally, so we don't need to go and download it again every time we run the code. Notice that this would download data and documentation within house prices object. Therefore, we're going to create a new object named house prices with only the data, therefore equals to house prices underscore object, and we get its .data attribute. To run these code lines, we're going to select them, and then we're going to press now directly F9 on the keyboard. And as we'll see, by clicking on the Variable Explorer tab, this created the two objects, house prices object with data and documentation, and house prices with only the data. So if we double click on any of these cells, this opens the data for us. In this video, we're going to focus on the following columns. First, at price, lot size, and bedrooms, and the reason for this is that we're going to fit a multiple linear regression in which price is the dependent or explained variable, which is being explained by the independent or explanatory variables of lot size and bedrooms. And then for wall test, we are going to add air conditioning as the dummy variable, and also the product of air conditioning with the independent or explanatory variables of lot size and bedrooms. Notice that air conditioning has values of no's and yes. This will be automatically converted by Python into a dummy variable or a binary variable with zeros for no's and 1 for yes. If you want to read the full documentation of the data, you can do so with the following code line, which is print, and from house prices underscore object, we get its .2 underscores doc 2 underscores attribute. As it is a single code line, we directly press F9 on the keyboard, and we can see the full documentation being printed right here within the console. So if we scroll up, we see house prices are documentation. So now we continue with step number 3, which is the model. For this, we're going to create an object named MLR, which stands for multiple linear regression, and this is equal to SMF feature from statsModels.ols or linear least squares function, and within it the following parameters. Formula equals to, and within quotations because this is a string, and we have the following. Price, which is the dependent or explained variable. This special character means being explained by the independent or explanatory variables of lot size plus bedrooms. And then for wall test, we're going to add air conditioning, which is the dummy variable, and then we have here plus and an inverted diagonal so that we can continue the string below. As mentioned previously, product of lot size multiplied by air conditioning plus, and then we have bedrooms multiplied by air conditioning, and then we have data equals to the house prices object we created above, and we go ahead and fit this regression, open and close parentheses. Then we're going to proceed to print the results. So we do so at the beginning of the code line here. print, and we print the summary results from MLR object with .summary method, open and close parentheses. So let's go ahead and run these code lines by selecting them, and then we're going to press F9 on the keyboard. And as we'll see, this creates the MLR object within the variable explorer, and also it prints the results for the regression. So let's scroll up, and we see the summary results for this OLS, or ordinary least squares regression, and specifically we want to focus on the coefficients here. So we see that they begin with intercept, and specifically we want to focus on the ones for the dummy variable. So we see air conditioning with t.yes. So as mentioned previously, Python automatically converts the data into a dummy variable or a binary variable in which no's are zeros and yes are ones. Therefore, here we have air conditioning when it is 1 or yes, and also it applies to the products of lot size multiplied by air conditioning when it is yes, and bedrooms multiplied by air conditioning when it is yes. Something very important about the notation of how the coefficients were printed here with the brackets of t.yes with capital T, and also here that instead of having the multiplication symbol, we have semicolon. This is important because once we do wall test, we will need to write the null hypothesis with this notation. So now we're going to continue with step number 4, which is homogeneity. And we're doing walled test. So for this, we're going to create an object named walled test, which is equal to, and from MLR object, we're going to get walled underscore test function, and within parentheses, the following parameters. Our underscore matrix equals to, and within quotations, we are going to write the joint null hypothesis for wall test, which is as follows. So as mentioned, is air conditioning, and within brackets we have t.yes, so it needs to have exactly the same notation as we have here within the results. It is equal to, and then we have the first of those corresponding products, which is lot size semicolon. This is very important. Air conditioning, also with t.yes. And what we're going to do here is we're going to move this into the following row. So here we are going to do again another inverted diagonal and pressing enter on the keyboard. And this is going to be equal to, and again using the inverted diagonal and continuing at the following row, we have the next product which is bedrooms semicolons air conditioning t.yes, and all of them equal to 0. So what we can see here is the null hypothesis that air conditioning, the product of lot size multiplied by air conditioning, and the product of bedrooms multiplied by air conditioning all are equal to 0. As we see, we change from the multiplication sign to semicolons in both of the products, and we added the t.yes here in all of them. Comma here, use underscore f equals to true so that it performs an f test. So this is a walled f test with a joint null hypothesis that dummy variable and dummy variable products with independent variables coefficients are equal to 0. Notice the dummy variable chosen, in this case air conditioning, and the f test with use f equals to true parameter were only included as educational examples, which can be modified according to your needs. So then we want to print the results for wall test, so we do so at the following row, again at the beginning, and we do so with print, and within parentheses we have walled test. So we're going to select these code lines and we're going to press F9 on the keyboard directly, and we see that the results have been printed right here within the console. So we have wall test F statistic, number of degrees of freedom, and the F statistic p-value. This is the wall F test p-value with the joint null hypothesis that air conditioning and air conditioning products with lot size and bedrooms coefficients are equal to 0. If rejected, linear regression intercept and or slopes are not homogeneous, or there are changes in intercept and or slopes when house prices are classified according to houses having air conditioning or not. If not rejected, linear regression intercept and or slopes are homogeneous, or there are no changes in intercept and or slopes when house prices are classified according to houses having air conditioning or not. Okay, so with this we finish with the code file, so we can go ahead and save it And with this, we also finish with this video. Thank you for watching.